Hello everyone, Siddharth this side, and in this video we will be solving another question on Geek for Geeks, which is depth first search of an graph. So we have given an connected and undirected graph, and we have to store all the given nodes of this given graph into an array list, and we have to return that. So I would suggest that you can first solve the question that which I had solved earlier, which is breadth first search, because from moving on to from moving on from breadth first search to depth first search will be easy for you, because these two approach is quite similar. uh, we just have to change from the level by level method to uh, recursive method, and we can able to solve this question as well. So let's see how we can solve this question as well using depth first search. So what we had done in the breadth first search is that we have used Q, and we have traveled the graph level by level. So instead of that, we will be finishing first branch first and then moving on to the next branch. So this is in given adjacency list 231. So 231. So 0 is connected to 231, and then 0 0 4 0 0 4, and then 0 2, and then 0, and then 2. So 1 is connected to 0, and 2 is connected to 0 and 4. 3 is connected to 0, and 4 is connected to 2. Now, how we can solve this question? So let's draw the graph first. That then it will be easy for you. So 0 2 4, 0 2 and 4, and then 3, and then there is 1. Okay. So now instead of traveling level by level, like for completing all the nodes of 0, then moving on to 4, which is the neighbor of 2, we will be moving to 0 2 then 4. So you're getting clear idea how we can do how we will do this. So what we will do, we will make a boolean array same as what we had done in breadth first search. So we will in the first recursive call, we will mark 0 as visited into our boolean array as true, and then we will be adding this 0 into an array list. So we will be adding 0. Now we will move on to this index, which is 2 3 and 1, as 0 is connected to these three nodes. Now we will move on to its first element, which is 2. Now what we will do, we will again check if this is visited or not. So it is not visited here, so what we will do, we will mark this as visited as well. So this is also visited, let's say true here. And now we will add it to into an array list. So after doing this, we will be again calling DFS for this node. instead of uh, instead of instead of moving on to its neighbor, we will be calling DFS again for this node. Okay, so after after marking 2 as visited as true, now we will be again pass this 2 into an DFS method again. And now we will check if it is visited or not. So if it is not visited, then we will mark that as visited, and we will move on to the next element. So this is visited. So now we will get now we will again check for tooth index. So 0 1 2, which is 0 and 4. Now we will move on to this array list, and we will take out its first element, which is 0. Now we will again check if 0 is visited or not, which is it is visited. So uh, we will be moving on to the next element, which is 4. So 4 is not visited. So we will again call this DFS method for 4, and then we will marking 4 as visited. So 0 1 2, this is 3 and 4. Now we will be adding true in the fourth index as well, and then the element which is present in the fourth array list is 2. So we will be checking if 2 is visited. So it is visited already. So now we will backtrack from here, because this we have already completed the whole array list here. Now we will be backtracking from here. So the last call that we have called from is tooth index. So this array list is also got completed. So now we will moving on to the first time we have called uh, we have we have called the DFS method, which is 231. Now we will start from 3. So 0 1 2 3. So 3 is not visited. So we will move on to this array list, and after getting out the first element, it is visited. Now we will be calling DFS for 1, because this is the last element of this array list. So now we will move on to this element, and this is also visited. So now we will this whole array list is visited. So in this way we can solve this question. Okay, now let's move on to the coding part, how we can solve this. So in this method, first we have to initialize an array list, and this should be AL or result is equals to new array list integer. This should be like this, or we can remove this also. Now after this, what we have to do, we have to call our DFS method. So DFS, we will be passing 0 as a first vertex. Then we will be passing this adjacency array list, adjacent array list, and then we will be passing our result array list, where we have to store the data, and then we will be returning this result array list. So let me do that. Now after doing this, we just have to complete this array list DFS method to public. So this will be returning, we can make it as void. So void DFS, we will be getting vertex, and then we will be getting an array list of an array list, which is ADJ. And after pasting this, now we will be having our array list of results. So let's copy this out as well. Now let's make it leftwards. Now after doing this, we just have to add this. We will have to mark this as visited. So let's make a boolean array as well. Boolean visited. So to new boolean, and the what should be the length? It should be adjacent dot size. Now after doing this, we have to pass this as well into our DFS method. Sorry, this should be visited. Now let's copy paste this also. So boolean visited, comma. Okay. Now after doing this, we just have to add this and mark this as visited. So result dot add, we will be adding the current vertex that we have got, which is V. Now after that, we have to mark this as visited as well. So visited of V should be true. Now after this, we have to check if the neighbor of this current node is visited or not. So for that, let's initialize in for each loop. This is what we had done in breadth first search also. So int I and adjacent dot get, and this should be the vertex that we have just got. Now after that, what we have to do, we have to check if visited. Let's make draw an not operator as well, and visited of this current I is not true. Then in this case, we have to mark this as visited. So visited I is equals to true. Should be visited I should be true, and then we have to call DFS again for this given node. So DFS, we will be passing the current vertex as the current I value, and then we will be passing the same adjacency list, and then we will be passing the result, and then we will be passing widget boolean array. Now after the completion of all the recursive calls, we will be having our result stored into a result array list, and we will be returning here that as well. So let's try to run this code and see whether if there are some issue. Okay, let's try to submit this as well. All the test case have been processed.